All right, so now that we have learned a new strategy to deal with mixed numbers, we're going to look at a word problem and keep those tools in mind so that we can use them to help solve this problem. So, Mr. Mitchell lost 10 pounds over the summer by jogging each week. By winter, he had gained 5 1/8 pounds. So, represent this situation with an expression involving signed numbers, and then what is the overall change in Mr. Mitchell's weight? Okay, so now that we have created a mental movie of what is going on in this problem, I want you to use the annotations that I circled and highlighted, and I want you to write down what is important and what the question is asking us to find on your paper. So I'll read it one more time. Mr. Mitchell lost 10 pounds over the summer by jogging each week. By winter, he had gained 5 1/8 pounds. We need to represent this situation with an expression involving signed numbers. And then the question is saying, what is the overall change in Mr. Mitchell's weight? Okay, so Mr. Mitchell lost 10 pounds, so I highlighted that. It then said he gained 5 1/8 pounds. So we need to represent this situation with an expression involving signed numbers. So in other words, positive and negative numbers. Then it's asking us to determine what is the overall change for Mr. Mitchell's weight. So we have two things going on that we need to have before we're finished with this problem. So I numbered them on my paper. So first, what is going on with Mr. Mitchell? Well, he lost 10 pounds. So how could I show that in a visual representation? Well, I know that when we deal with positive and negative numbers, a number line will show what is going on really well. Okay, specifically what direction we are moving during our problem. So let's go ahead and draw a number line for our draw portion of read, draw, write. So where do we always start on a number line? At 0. Okay, so then if he lost 10 pounds, what direction would we move? Well, he's losing 10 pounds, so we would move in the negative direction 10 spaces. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I could show every single space that I jumped, right, with the dash marks. And I could number every single one if I wanted to, but just for efficiency, I'm just going to number the negative 10 that we landed on. Then, now that he's lost that 10 pounds of weight, then what happens? Well, then it says he gains 5 1/8 pounds. Okay, so what direction would we move now if he's gaining weight? Well, we would move in the positive direction, those 5 1/8 spaces. So here we go backwards. 1, 2, 3, 4, 5, and then like a little bit more because that is adding 5 1/8. I'm so sorry. Let me also show my negative 10. So negative 10 was the green, and 5 1/8 was the pink. All right, so where did we land? Well, it's kind of hard to see, but somewhere in there we landed between these two numbers. So if I showed it on my number line, -1, -2, -3, -4, and -5. So it's somewhere between -4 and -5. But since we don't know where we landed exactly, let's go ahead and write that mathematical expression so that we can solve it and determine what number this is specifically. So I see that we started with a -10, and then we added 5 1/8 pounds together. So now we have our math expression, okay? But then we just learned that we can break apart a mixed number and turn it into an addition problem. So I'm going to try that. So I'm going to break up that 5 1/8 apart into 5 plus 1/8. And I still have my -10 here. We haven't done anything with that. So let's go ahead and rewrite that. All right, well, what could I combine first to get us even closer to an answer? Well, I know I can combine -10 and 5, and so that might actually make it a little bit simpler to deal with the whole numbers first before dealing with the fraction. And so making my tic-tac-toe chart again, if I have a negative and a positive being added together, I see that in my table, I need to subtract them and keep the sign of the bigger number. So I'm going to zoom down. So 10 minus 5 we know is 5. And since 10 is bigger, that means we are still in the negatives, which makes sense because we're still on the negative side of our 0. And then we have the plus 1/8 because we haven't done anything with that. All right, well, now I see that these numbers have different signs, so I know that I cannot add these numbers to get 5 1/8 or -5 1/8. This is super important because we still follow our integer rules as shown in our tic-tac-toe chart. So if we have different signs, let me get a different color. If we have different signs, so a negative and a positive, which is that second row. It's the second row right here. Then I need to subtract them once more and keep the sign of the bigger number. Okay, well, if we're going to subtract 5 and 1/8 together, I know I could convert this fraction to a decimal if I wanted to and then subtract. But since we've been dealing with fractions this entire lesson, I'm going to continue to review fraction operations and subtract these numbers together. So how do I subtract a fraction from a whole number? So if I rewrote this, it would look like 5 minus 1/8. Well, I know that we have to first rewrite 5 as a fraction. So I know that 5 over 1 is the same thing as 5 wholes, because if I divided 5 divided by 1, I would go right back to 5. Okay, so now I have 5 over 1 minus 1 over 8. Can I subtract 1/8 from 5 wholes? No, because I need to have the same amount of pieces cut into each fraction before I can subtract, right? So I have 5 whole pies, but I don't know how many pieces they're cut into right now. So I have to take them and cut them into 8 pieces before I can take an eighth away from it. So in other words, the denominators need to be the same before I can subtract them. So what denominator could they both become? Well, I know I can multiply 1 to get 8, so let's go ahead and do that. So 5 over 1, let me do this over the side, times 8 would get me a denominator of 8. But what I do to the denominator, I have to do to the numerator. Remember, we keep things balanced in math always. And so now I multiply my fractions straight across, and 5 times 8 is 40, and 8 times 1 is 8. Okay, so now I have rewritten my 5 over 1 into a improper fraction, which makes sense because if we simplified 40 over 8, we would get right back to 5. Remember, 40 divided by 8 is 5. Okay, so now can we subtract? Well, yes, because we have 40 out of 8 whole pies, right? And I'm going to take away one of those 40 pieces, okay? And I'm going to see what I'm left with. So I'm left with 39 pieces of these pies when each of them are broken up into 8 total pieces. So let's go ahead and simplify this answer. So we know we're going to divide and see how many 8s go into 39, which I see is 4 times. And then we're going to stop, and instead of changing it to a decimal, we're going to leave it as a mixed number. So reviewing our mixed number rules, I know that I have my 3 parts to my mixed number here in our division problem. So 8 goes into 39 4 whole times, with a leftover of 7 when we cut them into 8 pieces. So we have an answer of 4 and 7/8. But which number was bigger again? Well, since the 5 wholes is bigger than the 1/8, that means our answer is going to be negative. Okay, which makes sense if we look back at our number line. We were still in the negative section of our number line, so we were at negative 4 and 7/8. Awesome. So now that we've figured out the exact number that we're at on our number line, let's go ahead and answer our question in a complete sentence. So it says, what is the overall change in Mr. Mitchell's weight? So let me zoom out and write our sentence. So the overall change in Mr. Mitchell's weight is, we could say, negative 4 and 7/8 pounds, or we could change that negative to a phrase by saying a loss of 4 and 7/8 pounds, because when we say the word loss, that is implying that negative sign, so we don't have to then put it in our sentence. So the overall change in Mr. Mitchell's weight, is a loss of 4 and 7/8 pounds. Great job.